Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. My name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss the topic design approach of PLA. Okay, PLA, Programmable Logic Array. Right, Programmable Logic Array. Before going to know the PLA, so it is one type of programmable logic devices. Programmable logic devices. We call it is PLDs. Okay, PLDs. So PLDs. Let us see the PLDs. These are the two types of design. PLDs design two types. So one is PLA, which we are going to design approach of PLA and PAL. Okay, PAL and PLA. Programmable logic array, programmable array logic. Okay, so what is PLD? So PLA is a part of PLDs, right? So PLDs are programmably designed. Okay, so programmable. So it creates a specific applications. For specific applications, specific applications for specific applications okay, for specific applications, so the devices are designed by programmably. Okay, so specific applications PLDs are used. Okay, specific applications, right? We call it is ASIC applications, specific application specific integrated circuits. Okay, so PLDs are create an application with the programmable devices. So it create an ASIC. Okay, application specific integrated circuit. It is called application specific IC, integrated circuits. Okay, it create an ASIC. So programmably. Okay, programmably. So programmable. According to the programmable, a specific applications, the devices are created. Okay, so according to the programmable logic gates are designed. So programmable logic gates. Okay, logic gates. Programmable logic gates and programmable switches. Programmable switches. Okay, so programmable switches. Okay, programmable switches. So programmable gates, programmable switches designed in PLDs. Okay, so mostly used in programmable ROM. Okay, so read-only memory, right? Programmable designed by ROM and programmable read-only memory. We call for specific applications ROM, PROM, and sometimes we can rewrite a program. So EPROM, rewrite a program for the another applications. So for the further applications, we can use these PROMs, erase the data and rewrite the program for another specific applications. We call it is EPROM. And in flash memories, flash memory, right? Flash memory. So these are the programmable logic devices in a specific applications. So PLDs are used. So it create an ASIC application specific integrated circuits. So programmably designed by a specific application ICs. Okay, right? Programmable logic gates. Logic gates and switches are designed. Okay, used in ROM, PROM, EPROM, and flash memory. Okay, flash memory also used in microprocessors. Okay, microprocessor for programming purpose. Okay, program stores in that processor. Okay, micro microprocessors. So for programming. Okay, so program storage or programming applications. Okay, microprocessors for programmable devices. Programmable. Okay, programmable devices. Right, in microprocessors, in ROM, PROM, EPROM, double EPROM, and flash memories. So according to a specific application's memory used in programmable logic devices and also in microprocessor. So then according to the program, it creates one device. So programmable devices, right? So let us see this one. VLDs are we call inputs and outputs. Okay, inputs and outputs are logic gates, logic variable inputs. Okay, logic variable inputs, right? Logic variable outputs, logic variable outputs. Okay, so logic gates, variable inputs, logic variable inputs. You can say it is logic variable inputs, ma. Variable inputs, logic variable outputs, logic variable outputs. So logic means zeros and ones. So variable outputs, variable output, logic variable outputs. So inside of this one, so logic gates and programmable switches, programmable switches. So according to program, the gates will be on and off, the switch connections, programmable switches, right? Programmable switches. This is about the block diagram of PLDs, block diagram of PLD, block diagram of PLD. So PLDs are classified into two types. So PLDs are classified into two types. So PLDs are classified into two types. So one is PLA. Okay, PLA. One is PLA. Second one is PAL. Okay, so this is PAL, programmable logic array. So this is called programmable logic array. Programmable logic array. Okay, logic array. And this is programmable array logic. Programmable array logic. Programmable array logic. Okay, so in this both planes, underplanes, R planes are programmable. Only underplanes are programmable. R is fixed. So let us see the design approach of PLA. Design approach of PLA. Okay, design approach of PLA. Okay, PLA, programmable logic array. Programmable logic array. So let us see the block diagram of. So in this underplanes, R planes, both are programmable. So let me see this one. This is underplane, gates. Okay, gates. We are applying inputs. So on inputs. Okay, inputs and outputs are outputs. From the outputs, so we can connect to this R plane output. Okay, so inputs, these are the inputs. Okay, and this is AND plane, AND gates, AND gates, AND gates, and which are connected to these OR gates, connected to these OR gates. Okay, connected to these OR gates. So input, it will be ask you examination, you can draw and explain. And this is OR gates, OR gates, and outputs. These are the outputs. Outputs. So both AND gates and OR gates are programmable. In PLA, in PLA, in PLA, in PLA design, in PLA design, okay, AND gates, AND gates, OR gates, AND gates, OR gates programmable, AND gates, OR gates programmable, AND gates, OR gates are programmable. Okay, AND gates and OR gates are programmable. Okay, so this is a programmable and programmable OR. So according to the input program, the AND gates will be run by program, and AND gates are connected, and also OR gates are connected switches. Okay, according to the program inputs, when you are connecting to this program, according to the program, AND gates, OR gates are programmable connection. Programmable connection. Okay, so let us see this one in clear information. So programmable switches. Okay, programmable switches. Let me take this one. Inputs are here. Okay, inputs are here, and can take one complemented gate. Okay, complement input. This is a complemented input. Let us take that three input variable representation, three input variable, and a complement representation. Okay, you can see this one, three inputs. Let us take this three inputs. So this is a complement input. Let us take this one x1. Okay, and this is x2 complement, x3 complement. This is x3. So x1, x2, x3 are inputs. These are the inputs. Okay, input variables. Okay, input variables. So these are connected to the AND plane. Okay, AND plane. You see this one. AND planes are here. X complement. Okay, x2 complement, and x3 complement. X3 complement. So you can take the switches according to the switches which will be connected over here. Okay, programmably it will be connected according to the logic. Okay, so this is AND gate. This is AND gate. Okay, this is AND gate. Now let us take another AND gates. Okay, x1 complement, x2 complement, x3 complement. Okay, so this is x1 complement, x3 x2 complement, and x3 complement. So this is also one AND gate. Okay, switches, programmable switch connections. Okay, let us take the two product terms. Let us take three product terms. The another programmable switch. You can see how many switches are here. Three inputs. Switches are x1, x2 complement, x3 and x3 complement. So 6 switches are here. Okay, 1 2 3 4 5 6 switches are connected to the AND plane. Okay, so x1 again, x1 complement, x2, x2 complement, and x3 complement. Okay, then here also the AND plane connections, switch connections, x1 complement, x2 complement, x3 and x3 complement. Okay, so this is an AND gate again. Okay, so from here, so after this we can take the product terms P1, P2 and P3. So according to the switch connections, the OR gate outputs, this is OR gate output. Okay, this is OR gate output. This is OR gate output. So function F1. So again, another OR gate output. So P1, P2 and P3, P1, P2 fuse connections. Okay, so which can be taken output as OR gate. Okay, you can see this is OR gate F1 and this is F2. Okay, so let us take the function F1. Here the fuses are connected. F1 is equal to, let us take F1 is equal to, so the product term F1 is equal to x1 x2 plus x1 x2 plus right x1 x2 and second product term, let me take this x2 x3. Okay, so x1 x2 product term P1, this is a product term P1 this is product term P1, this is product term P1, product term P2, product term P2. Let us take the, what is the product term here, x1 and x2, x1 and x2, x1 and x2, this is x2. Okay, x2. So x1 in this one, x1 connection over here, the fuse connection over here, x1, and x2 is this one, this portion. So x2 is connected over here, the fuse connection. So this is a product term P1, this is product term P1. Okay, now again product term P2. What is the product term P2? So AND gate product term P1 and P2. So P2 is nothing but, this is a P2. So P2 is x2 and x3, x2. So x1 complement x2. So this is x2 this is x2 and x3. Where is x3? This is x3. Okay, so the fuse connection. So according to the variables, product terms and OR gates, so according to the programmably this is connected. According to programmable, it will be connected P1 and P2. So P1 is x1 and x1 and x2. So P2 is x2 and x3, right? And P3, let us take the function F2. Okay, now function F2, let me write here, let me write this F2. Okay, so this is F1, where F2 is equal, and let me connect this one also. What is F1? F1 is equal to x1 x2 P1 P2. So how many product terms are here? Two product terms, x1 x2 x2 x3. So two product terms are connected in switches P1 P2. Okay, P1 P2. So let us take F2 is equal to, this is F2 function output, functional output, OR gate output from the product terms. So product terms are according to the input. Okay, input. Let us take this right x1 x2 x1 x2 x1 x2 plus right x2 complement and x3 complement, x2 complement and x3 complement. So F2, so this is P1 again, x1 x2 are the P1 which were already taken, x1 x2 and x2 x3 complement, this is nothing but product term P3. Okay, so P1 P2 and P3, right? P1 P2 P3. Let us take this where this x1 x2 is already there, so we can directly take this P1. So P1, directly take this one. Okay, x1, x2 is already connected, product term P1. Now what is a P3, x2, x3 complement? So product term P3, it is nothing but this is a P3. This is a product term P3, product of two variables. So what one is x2 complement, x1 complement, x2 complement. So this is x2 complement. Okay, so this is x2 complement, x1 complement, x2 complement. Okay, now x3 and x3 complement. So this is x3 complement. Okay, the fuse connection over here, connecting from here to here. According to the fuses, the signal flow, then the variable value 0 or 1, which will be connected to the programmable. Programmably, the switches are connected according to the product of this x1 and x2, and x2 and x3, x2 complement and x3 complement, product of P3. So now the switch will be connected over here. So P1 and P2. P1 is connected over here. Now P3 is connected over here. Switch connected over here. You see, so F1 is equal to P1 P2, P1 plus P2. F2 is equal to X1 X2 plus X2 X3 complement. Let me write this first one, where P1 is equal to X1 X2 P2 is equal to second product term X2 and X3, and P3 is equal to x2 x3 complement. So function f1 is equal to P1 plus P2. So we can write this function f1 from that P1 plus P2. So P1 is equal to product term P1 is equal to x1 into x2, right? F2 is equal to function f2 is equal to the functional OR gate f2 is equal to x2 complement x2 and x3 complement according to the input binary which you are giving. So then the fuses are connected, the product term value is connected to fuses, then it will be OR gate. So it will be OR gate, finally OR gate output will be taken. So finally OR gate output x1 x2 x3 are the input variables. Okay, input variables. So we can design any number. Okay, any number in PLA. It will be 16 input 32 product terms, and 8 functional or OR gate outputs are there in design. Okay, so in design, in PLA design, okay, in PLA design, so we can use PLA design, use 16 inputs. So 16 variable inputs. 16 variable inputs. Okay, 16 variable inputs. Product terms are 32 product terms. Okay, 32 product terms. So product terms are used, 32 product terms, and 8 functional outputs, 8 OR gate functional outputs. Okay, functional means OR gate. This is OR gates. Okay, 8 functional outputs. 8 functional outputs are used. 8 functional outputs are. So PLA design, it is programmably UNDPLANE and OR plane. This is UNDPLANE. Programmably switches are connected according to the product terms. So each product term is nothing but a variables of x1, x2, x3. So product term P1, product term P2, product term P3. So F1 is a functional output. Okay, functional output which will be taken from the product terms. So any function will be taken, any boolean function will be taken. So F1 is equal to P1 plus P2. So P1 is a product term. So P is a product term. So we call it is product term. P1 is product term. So product of variables. Okay, product term. So this is a product term, right? Product term. We call it is product term. Okay, P1 is a product term of x1 and x2 variables. P2 is equal to x2 and x3. So according to x1, X2. So the switches are connected. You see this one. The switches are connected. So product term P1, product term P2, X2 and X3. So this is X2, X2 complement, X3, X2 and X3. P3 is X2 complement and X3 complement. So according to the product term, okay, product term, the outputs are connected to the R plane. Outputs are connected to the R plane. So AND gates and OR gates both are programmable. So programmable inputs are connected to these AND planes with the switches. Okay, all AND planes are connected to the OR gates. So OR gate outputs. So this is the OR gate output which are taken. We are seeing this one in the diagrammatically in detailed representation. So diagram is a detailed representation of PLA. You can write this detailed representation of PLA. Detailed representation of PLA. Okay, representation. Detailed representation of PLA. Okay, PLA, programmable and programmable OR. Okay, programmable and programmable OR according to the switch connections. According to the switch connections. Let us say the last another way you can represent this. Another way we can represent this. We can also represent this in this the cross representation, a schematic representation. We can also call it as schematic representation. So we have this the same thing we can represent in a schematic representation. Okay, the schematic that is a in detail fuse connection representation. In detail fuse connection representation. So here we can represent the product terms and OR gates like a schematic, a cross representation. Okay, so let us see, this one is X1 and X2, X1 and X2 inputs and X3. Okay, X3 complement. So let us see this one. How many product terms are here? 3 product terms are here. So one is P1, okay, and P2 and P3. Okay, these are connected to this AND planes. These are connected to the AND planes. Okay, these are connected to the AND planes. So let me take this product term P1, product term P2, product term P3. Okay, so P1, P2, P3, which are connected, outputs are connected to the two functional OR gate outputs. Okay, so this is OR gate output, this is OR gate output. Okay, another one, 2 OR gates are here, 2 OR gates, the functional 2 OR gates, and how many product terms? 3 product terms are here, 3 product terms. This is F1 and this is F2. So what you are taken, you can take the cross, okay, cross representation. Okay, the cross representation, the connections. Let us see what is the X1 and X2. X1 and X2. So this is X1 and X2. Product term P1. Product term P1. Right. The another one is what is a product term P2? P2 is X2 X3. X2 and X3. So this is X2 and this is X3. So product term P2. Product term P2. Okay, product term P2. What is the product term P3? P3 X2 complement and X3 complement. X2 complement and X3 complement. This is product term P3. Okay, product term P3. So what is the function F1? What is the function F1? F1 is equal to P1 plus P2. P1 plus P2. So P1 is here and P2 is here. Okay. Now what is F2? F2 is P1, P2. P1 and P3. Okay, P1, product term P1 and product term P3 is there. So this is a schematic representation of PLA for 3 input variables. So these are the inputs. Okay, so input variables, x1 x1 complement, x2 x2 complement, x3 complement. Okay, we can also say this is a bubble representation, complement of x1 x2 x3. So product terms, then functional outputs, and this is a functional outputs. So AND plane, OR gates. Okay, OR gates, and this is AND gates. Okay, AND gates. Okay, AND gates and OR gates are programmable. Okay, programmable like a switches in detail representation. This is a schematic representation. Schematic representation of PLA. Representation of PLA, programmable and programmable OR connection. So if any product terms, any functional variable is given according to this inputs and AND planes and OR planes, we can connect according to the switches, or we can represent in schematic. If any function is there, so we can represent in AND planes in a cross mark representation. Okay, so variable present, this represent a variable present. X represents a variable present. Okay, present in product term, variable present in product term. Okay, product. Okay, this is a representation. Cross mark representation, the variable present in the product term P1, P2 and P3 is a overall schematic representation. In detail representation, the fuse connections. Okay, so how many used in this PLA? 16 variables, 16 variable input, 32 product terms and 8 functional outputs are here. Okay, next class we'll see one of the problem on this. Okay, thank you. Please subscribe our channel, inform to your friends. Thank you.